This video is meant to provide a brief explanation for Lab 1 of Circuits 1. And apologies for the vertical video, it just works better with the layout that I have here. So if we're looking at our first lab, we have a power supply that's connected in series to a resistor and a rheostat, or a variable resistor. In this case, we're using a potentiometer. And in another video on YouTube, I explain how to use the potentiometer. I have my potentiometer here connected to leg 1 and 2. And besides that, we also want to have an overall current reading for our circuit. And we also want to read the voltage across the resistor. Now this is a voltage divider circuit. So if you look at how the potentiometer works, it works very similar to this if you're using leg 1, 2, and 3. But in this case, we're designing one ourselves, and we're just using this as a variable resistor. Before we start, I'm going to have components out in the lab that you will use. And just to be safe, we basically want to know what we're going to work with here to some extent. We're going to have one experiment in which we don't know this initial resistor, and one in which we do. But the resistance will vary from 39 ohms up to 75 ohms. And our potentiometer will be either one that reads from 0 to 50 or 0 to 100. If we have a resistor that is 39 ohms and our potentiometer is set all the way to 0, we want to calculate what is the maximum voltage that we can permit through our circuit. In this case, we use our power equation and P equals V squared over R to determine what is the safe voltage for the circuit. If our resistors are rated for 1/4 watt, we just want to replace that in the equation, and our lowest resistance. And there we get 3.12 volts as the maximum voltage when we have the least amount of resistance. So I want to emphasize for this lab, we want to use 3 volts on the power supply, and we don't want to exceed that. Our current limit we can set to 80 milliamps, and it should be sufficient. If we have to adjust these values a little bit depending on what resistance you're working with later, so that you get a little bit more sensitivity in your measurements, I can work with you there. But just make sure that when you're doing this experiment with a 39 ohm resistor, which is the known resistor, that you have your power supply set on 3 volts. Okay, looking at the physical circuit, I connected my power supply to my circuit going into the resistor, and then I have this diagonally placed potentiometer here. I'm using leg 1 and 2, and out from that it connects to ground on my circuit. Then I take my multimeter here, and it's in DC voltage, and I place that across the resistor. So I'm going to read the change in voltage as I vary this resistance. So right now I have the potentiometer set all the way clockwise, and that's the maximum resistance that it offers. And what I want to do is, as I change this resistance, I want to read the change in voltage and the change in current and plot that. So we won't use a second device to read the current. All we have to do is read the current from the power supply itself. It's going to be close enough. It's not as sensitive as a multimeter, but it's going to be good enough for us to actually do our experiment. So I'm skipping a few steps here, but I've already done this experiment, right? The idea here is that once we do that and we plot those points, we're going to get a regression line. And if we're plotting, in this case, voltage over current, well, that's equal to resistance. So we can determine the resistance that we're working with based on the slope of this regression line. And of course, it intercepts with 0, because at 0 volts, you should have 0 current. So essentially, that's the experiment. It's fairly simple. Just try to be procedural about it and safe about it. If you have any questions, feel free to ask me during the lab. Thanks.